Now we have seen in the previous videos how to disconnect a graph by deleting the edges, right? And that one we call it as the disconnecting set. Now we shall see something called as edge cut. So what we try to do is, we'll try to separate out the vertices of the graph into two sets and then arrange the edges as if either edges are present completely within one set or they will cross over from one set to the other set. Now if you find out all the crossing over edges and if you delete them, then also we are going to disconnect the graph. That is why the edge cut is also called as disconnecting set. So let's see with an example. What I mean to say is, assume that this is the graph. So don't assume these circles initially, assume that this is a graph. Now I'll put all these vertices in one set and all these vertices in the other set, and now if you look at the edges, they will either be completely within a set or they will be crossing over from one set to the other set. Now whenever you have these crossover edges, it is clear that they are all forming a kind of bridge from this side to that side, isn't it? Now if you remove that bridge, if you remove all those edges together, it is anyway going to disconnect the graph, which means you are going to get more than one component, right? Now in that case, this edge set is nothing but a disconnecting set according to the definition, right? So what an edge set is, first you should be able to separate the graph into two sets. See this? So before going ahead with the definition, let me tell you about the terminology used here. So let S comma T is a subset of vertices of graphs, which means we are taking two subsets S and T which are from the vertices of the graph. We write S comma T for the set of edges having one endpoint in S and the other endpoint in T. So we are going to use this representation S comma T within the square braces just to represent set of all these edges, right? Now by deleting these edges, we will be able to disconnect the graph. Okay, now in this one I am just introducing the terminology. Now let's see the definition of the edge cut. An edge cut is an edge set of form S comma S dash. So what does it mean? If you are going to choose a subset of the vertices into one set, then all the remaining vertices should be in the other set. That is why S and S complement, right? Where S is a non-empty proper subset of V, which means if you consider that set of all vertices of the graph is here V of G, and if S is a subset of this, proper subset of this, let us say this is S, then S dash is nothing but all the remaining vertices, right? So which means you have to see that all the vertices are either present in one set or the other. If you have not chosen here, they should be present here, right? Now, and S dash denotes G minus S, which means complement. Okay. Now this entire set, so once you have you have taken a graph and you have written S here and S dash here, now these are the edges passing over from here to here. Now this is called as the edge cut. Now if you delete this, everything is going to get disconnected. That is why it is also called as disconnecting set. See this? Every edge cut is a disconnecting set. The reason is, if you delete all the edges which are crossing over, definitely you will be able to get more than one component. One component will contain more than one component you might get. See, in this case you will get, see, if you delete all this, you are going to get three components. This entire part will form one component because all of them are connected, and these three will form one component, and this one will form one other component. Therefore you may get more than one component, but then it is very sure that you will be able to disconnect the graph because there will be no edges for these vertices to reach from this side to that side. Got it? So every edge cut is a disconnecting set, but then every disconnecting set may not be an edge set. The reason is this. See, now A, B, C is the edge cut here. If I add E and D as well to it, which means if I delete all these edges A, B, C, E and D, I'll still be able to disconnect the graph. See, I'll be able to disconnect the graph by deleting these three edges. By deleting more edges, I'll still be able to disconnect it. Therefore, ABC is a edge cut and also a disconnecting set, but ABC, ED will only be disconnecting set. The reason is, you will not be able to get a partition of the vertices in such a way that all these 5 vertices, edges will be crossing over between those sets, which means whatever combination of edges, partitions you take, let us say you don't want to partition it this way, whatever other way you try to partition the graph, you can never find that A, B, C and E, F will be the edges which will be crossing from one set to the other set, right? Therefore, every disconnecting set cannot be represented as a edge cut, but then every edge cut is definitely a disconnecting set. Got it? Okay. Now let's see some more points on the edge cut. Every minimal disconnecting set of edges is an edge cut. So what is the meaning of it is, here they have used the words minimal disconnecting set. So what is the disconnecting set? By removing those edges, you should be able to disconnect the graph. Now what is the meaning of minimal disconnecting set is, you should not be able to, once you form a set, let us say, if you're calling it as the minimal disconnecting set, then you should not be able to get a disconnecting set by removing any of the edges from it, which means if you have chosen some edges, all these edges should definitely be deleted in order to disconnect the graph, otherwise it will not get disconnected. Now every minimal disconnecting set need not be minimum, that we have already seen, right? Okay, now let's see this one. In this graph, if you see it, A, B, C is a minimal disconnecting set. Why? If you remove ABC completely, ABC edges, all these 3 edges, the graph is going to get disconnected. As well as you cannot remove only any 2 of these and then disconnect the graph. Try it. If you remove only B and C, it will not get disconnected. If you remove only A and B, it will not get disconnected, right? So you have to remove all these 3 in order to disconnect the graph, right? And therefore this is minimal disconnecting set. Now based on this minimal disconnecting set, you should be able to divide the graph into 2 parts in such a way that only these edges will be crossing over these 2 sets. For example, you can put all these 3 vertices in one set and the remaining vertices in the other set. Now what do you see? We are able to partition the vertices into 2 sets in such a way that only these 3 edges are crossing over. Therefore, you can also call this as the edge cut. Got it? Okay. Now if you see one more example, CDE. CDE is also a minimal disconnecting set. Why? See this. By removing C, D and E, you are able to disconnect the graph. But then by removing only any 2 of these, you will not be able to disconnect it. That is why it is minimal, right? And now based on these 3 only, you should be able to partition the graph in 2 ways, 2 sets, like put all these in one set and put all these in one set, right? Now you can see that only C, D are crossing over the 2 sets. Therefore this is one more way of partitioning the vertices, and so you can call it as edge cut. So whenever you get a minimal, then you will definitely be able to partition the vertices in such a way that you are going to get an edge cut. Got it? And if you want to see one more, you can also think about these 2 edges. These 2 edges are also going to form the minimal disconnecting set. Why? If you remove these 2, this one is going to get disconnected and you are going to get more than one component. But if you remove any one of them, you can't do it, right? In fact, this is the minimum disconnecting set. Why? If you have to disconnect anyone in this graph, you have to at least remove 2 edges, because the minimum degree here is 2. Got it? Okay. Now you can put this one in one set and you can put all the remaining in the other set, and you can show that these 2 edges which were actually minimum disconnecting set, which means they are also minimal disconnecting set, is now going to be an edge cut. Got it? Okay. Now let's look at the next point. Deleting one endpoint of each edge in an edge cut F deletes every edge of F. Therefore vertex connectivity is less than or equal to edge connectivity. Okay, so I'll explain you what they mean to say by this. Let us say there is a graph, right? Now in this graph you try to find out the minimum number of edges that you need to delete in order to disconnect the graph. say you got these three edges, right? If you delete these three edges, you are able to disconnect the graph into two parts, right? Now, in order to delete these three edges, I can delete any one of the vertices which are adjacent to these three edges, these three vertices, and still I'll be able to disconnect the entire graph. Got it? Therefore, in worst case, I can disconnect a graph by deleting exactly the minimum number of exactly the number of vertices which is equal to the minimum number of edges required to disconnect it. Therefore, our vertex connectivity will always be less than or equal to the edge connectivity. When will we be lucky and when will we be getting a less one is, assume that you have to delete three edges, and three edges are like this. Let us say we have a graph like this and many edges or vertices are here, and you have a graph like this and many vertices are here, right? And now assume that this is the three edges you need to remove in order to disconnect it, and also this is the minimum set, let's say. Then what does it mean? You cannot disconnect this graph without removing all the three edges, but then if you delete this vertex and this vertex, that is enough to delete these three edges. Therefore, in some cases you might even get vertex connectivity less than edge connectivity. In worst case, your vertex connectivity will never be greater than edge connectivity. In best case, you might get less than that. Therefore, this rule is this is true for any graph, which means your vertex connectivity is always less than or equal to edge connectivity. Got it? Okay. If G is a simple graph, then vertex connectivity is less than or equal to edge connectivity is less than or equal to the minimum degree of the graph. See, this one we have already seen here. Now only thing I need to tell you is this one, right? So what does it mean? Edge connectivity is less than or equal to minimum degree of the graph. So let us say there is a vertex with least degree, right? Now by deleting these two edges, I'll definitely be able to isolate this vertex, which means I'll be getting at least two components by deleting these two, right? Therefore, in worst case, I need not go beyond this. In best case, I'll go less than this. In worst case, I need not go beyond that, right? So what is the meaning of it? In worst case, you will never have to delete more edges than the minimum degree of the graph. The reason is, if you delete these many edges, it is enough to disconnect the graph, right? Then why do you want to go for more? So you will never be able to cross that. So our edge connectivity will never be crossing the minimum degree, and our vertex connectivity will never be crossing the edge connectivity. Got it? Okay. Next one is, if S is a set of vertices in a graph G, then the number of vertices or number of edges in the edge cut S comma S dash is equal to sum of the degrees of all the vertices which are present in S minus twice the number of edges which are present in the that set S. So what is the meaning of that one is, let's take an example. Let us say you have a graph. Let us say, I'll just take this one. You have a graph like this. Something like this, and now this is the edge cut you got, right? I am able to partition the vertices of the graphs into two sets in such a way that one side there is S and other side there is S dash, right? Now how to find out the edges that are crossing over this one is, that are crossing the sets is, this is nothing but the cardinality of the edge cut, isn't it? Now how to find it out is, find out in total how many edges are incident on all the vertices which are present in this set. From that number, you try to delete the edges which are present inside the set. Then you are going to get the edges which are going out. That is nothing but the cardinality of the edge cut. Are trying to get this? Find out how many edges are totally incident on all the vertices which are present inside this set. From that number, you delete the edges which are present inside the set. Now you are going to get the edges which are going outside the set, which is nothing but the cardinality of the edge cut. Now this is the way they are doing it, right? Now if you observe it, they are finding out the total degree sum of the vertices present here. Now what will that give us? That will give us twice the number of edges where this edge E is total number of edges which are incident on these vertices. Got it? And from these we are deleting twice the number of edges. We are deleting twice the number of edges which are present in it, right? So I think we have to divide it by 2. Let me just test it. See this. Now what is that I am getting? By finding out the degree sum of all the vertices which are present in this set, I am able to find out twice the number of degrees, twice the number of edges which are incident on these vertices, right? So which means I am going to get 2 into E, where E is the total number of edges which are present here, right? And from that I am going to decrease 2 into E, where small e is the number of edges which are present inside it, right? Then what do I get? I am going to get 2 into E minus E. Now what is this E? The total number of edges which are incident on the vertices which are present in this set. And what is this small e? The total number of edges which are completely lying within this set, right? Therefore you have to divide it by 2. Okay? Okay, fine. Now let's see this point. If S is a set of vertices in a graph G, then the number of edges which are present in this edge set. So see, what is this representation? This is nothing but the edge set, and when I put it that, it is nothing but the cardinality, which means the number of edges which are present in the cut edge, which is formed by dividing the graph into 2 sets, S and S dash, is equal to sigma V belongs to S D of V, which means sum of all degrees of the vertices which are present inside one partition minus 2 into E of G of S, which means twice the number of edges which are present inside that particular set. So what I mean to say is, if you want to find out the cardinality of this cut, there is an edge cut, isn't it? By dividing the entire graph into 2 sets, one is S and other is S dash, I am able to form a edge cut. Now for this edge cut, right, now these edges are moving over, right? So what is the cardinality of this? 1, 2, 3. 3 is the cardinality. Now they are saying, in order to find it out, you can take any set, either you can take this set or you can take this set. And now, so since this is the smaller set, I am taking it. That is the only reason. Now you find out the sum of all degrees of the vertices which are present in one set. So let me say this one. So what is the sum of all degrees? Degree here is 2, degree here is 3, and degree here is 1, 2, 3, 4. 4. Right? Find the sum. So 2 plus 3 plus 4. So which is equal to 9. So we got 9. Now from that you subtract twice the number of edges which are present inside it. So 1, 2, 3. 3 edges are present inside this set. Right? Why? These edges are not completely present inside the set. Got it? So that is why only 3 are present. Now you multiply it with 2 and you subtract from it. So 2 into 3. So you are going to get a number of 3. So what is 3? 3 is the number of edges that are crossing over, which is nothing but number of edges that are present in the edge cut. Now why do you think that this is true is, when you are trying to find out the sum of all degrees, we got the sum of all degrees because of 2 things. One is, every edge which is present inside the set is going to contribute to you to the degree of to the sum of degrees, a sum of 2, 1 to this and 1 to this, right? And what about this one? This is also contributing to you, 1 here and 1 here, and this also contributing to the sum of degrees, 1 here and 1 here. But then when you look at the edges which are going out, they are actually contributing only 1 to the sum of degrees. Therefore every edge which is present inside the set is giving you a total sum of 2 to the sum of degrees, and every edge that is going out is giving you only 1. So if from the total sum of degrees, if you delete 2 into number of edges present inside it, then the remaining number is nothing but the degree which is contributed by the edges going out, which will be equal to the number of edges going out. If you want to clearly see this, let's not use these numbers, just see this. Now how do I get the degree sum? This edge is going to give you a degree of 1 here and a degree of 1 here, only this edge, right? And this edge is going to give you a degree of 1 here and degree of 1 here, right? And this edge is going to give you a degree of 1 here and degree of 1 here, right? Now if you look at this edge, it is also going to give you a degree of 1 here, isn't it? And if you look at this edge, this is also going to give you a degree of 1 here, this edge 1 here, right? Now from the sum of all degrees, if you delete twice the number of edges which are present inside it, which means you are deleting this and this. Now whatever is remaining is nothing but the degrees which are contributed by the edges going out. Now that is equal to the number of edges going out. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.